Now, for differentiation rules, right, I like to call these just an easy way of finding the derivative, right? Let's just have an example, right? Remember that we had, oopsie, sorry for that. We had something like this, whereby we had f at x was equal to 4 minus, let's say, 7x, right? And then the answer to this, when you are using first principles, right, the answer to this, you found that the derivative of f, right, was equal to -7, isn't it? This was the derivative from first principles. Now we can get the exact same solution from using differentiation rules. Okay, these rules, we have 3 of them, right? So rule number 1, but according to me there are just 2. Rule number 1 just says, if you have I'm just gonna give them as 2 rules. If you have anything in the form of if your f at x is in the form of ax to the power n, then the derivative of that will be a, which is this, times by the exponent, which is n. Then you have x as your variable, then you say n minus 1. Okay, that is rule number 1. I can give you an example, right? Let's say you have example number 1 here. Let's just say your f at x is equal to 2x squared. Now you can find the derivative using first principles, right? However, using the rule, we're just gonna say the derivative is equal to, then you say whatever is here, it's your 2, right, multiplied by your exponent, which is 2, and then you're gonna say the exponent minus 1. Okay, so you're gonna say 2 times 2 is 4, then you say the exponent is 2, you're gonna subtract 1, then you're gonna have 1. So your answer is just 4x. So the derivative of that is just what? 4x there. Right? That is how simple it is. Let me give you the second example. Let's just say our f at x is equal to -x to the power 4, right? So the derivative of that would be, we just say whatever is here, we see that here it's -1, right? So we're gonna say whatever is here times the exponent. Okay, so we're gonna say -1 multiplied by 4. Then you write the variable as it is, then you say 4 minus 1, so you subtract 1 from the exponent. So the derivative of f would be -4x to the power of 3. Okay, can we apply the same rule and then get this answer here? Well, it turns out that we can. Remember we had f at x is equal to 4 minus 7x, right? Then we got the answer here to say the derivative was equal to -7, right? How can we get it using rule number 1? So this is what we're gonna say. Well, in fact, before I can do this one, let me introduce rule number 2, right? Rule number 2 says that if you have f at x being equal to a constant, right, any constant, meaning any number or any letter that we are not respecting, right, you then see what I mean by that. The derivative of that will be 0. So let me give an example. So the derivative of this would be 0. So let me give an example. Example 1, let's say you have f at x is equal to 5. The derivative of that straight away is equal to 0. If you have, this is example 1. Example 2, let's say you have f at x is equal to -8. The derivative of that would be 0. Okay, what if we have where g at x is equal to p squared? The derivative of that would be 0. Why? As long as we don't have x there, then the derivative would be 0. But if I had x here, the derivative wouldn't be 0. Okay, if I had x here, the derivative wouldn't be 0. Let me give you more examples. Let's say you have let's just say you have grx, right? Let's say you have grx is equal to let's just say 5x squared plus 6, right? So how would you get the derivative? Combine the two rules. Okay, so you're gonna say the derivative of g would be equal to whatever is here times the exponent, meaning 5 times 2, right? So you're gonna say 5 times 2, then you're gonna say the exponent minus 1. Okay, then because this is a number, because that is a number, it is a constant, so the derivative of that is just 0. So the answer would be that the answer would be 10x. That is the derivative of that. And you can actually try using the first principles from this, and then you're gonna get that the derivative is 10x. All right, so for that example that we then said there, right, we had f(x) is equal to 4, right? 4 minus 7x. We said, remember, the derivative was equal to -7. So now we're gonna prove it. So to get the derivative here, we're gonna say we go along all the terms. So the first term is a number. Is there any x attached to it? No, so the derivative of that is 0. It means this is a constant. Then look at here. Is there x attached to the number? Yes. If we have x attached to a number, let's remember that it's in the form of this. So what are we gonna do? We're gonna say whatever is here times the exponent. Remember, the exponent is 1. So you're gonna say -7 times 1, then you say x, and then you're gonna say 1 minus 1. Okay, so now the answer would be, right, the answer would be 0 minus 7, right, and then x to the power of 0. All right, so 0 is just nothing there, right? So and then -7, where x to the power of 0, which is 1. So we just have -7 times 1, which is -7, because any number to the power of 0 would be 1. So this is the derivative there, and as you can see, it's the same as what we got there. All right, so the differentiation rules are a way for us to get the derivative much faster. Okay, so like I said, I introduced them to you as 2 rules, but there are actually 3. The other rule says that if you have f(x), right, if you have f(x) is equal to ax, as long as the exponent is 1 there, then the derivative of f will just be the coefficient of x, right? This is rule 3 there. So what do we mean? For example, right, for example, let's say you have f(x) as being equal to 8x, right? Because there is an x attached to the 8, you can't say the derivative is 0, right? So because here the exponent is 1, the answer, the derivative of f is simply 8. We're just going to take the coefficient of that as your derivative. But I was saying you can still apply rule number 1. You can still say the derivative of f would be 8, right, multiplied by 1, which is the exponent, and then you say the exponent minus 1. So you would have 8 and then x to the power of 0, and then you get your answer as 8, because x to the power of 0 is 1. So you see, we still get the same answer, just that this one is going to be a bit long. Okay, it's going to be a bit long, but this one would be very fast. Okay, so you just check, as long as the exponent is 1, the anything that is next to x there, meaning your coefficient, will be the derivative. Let's give you another example, right? Example 2. Let's say you got grx is equal to -6x, right? What would be the answer there? Well, the derivative of g will just be equal to -6, because the exponent here is 1. If you want to go the longer route, you can say, since I have my grx as -6x to the power of 1, then the derivative of g would be negative 6 times 1, right? And then you say x1 minus 1, right? Remember, you say whatever is here times the exponent, and then you say the exponent minus 1. So you would have negative 6x to the power of 0, which is still negative 6. So you can do it like this, or you can go like that. Okay, you will see the one which works for you there, right? Which one works for you there. So now we're gonna do some more of bit of complex examples, applying the 3 rules. Okay, now let's say you have the following. F at x is equal to 3x squared minus 5x to the power 4, and then plus 2x minus 10. So you can give it a try, right? You can pause the video and give it a try, and then check the solution. So now the derivative of f here would be, I look at this and then I say the exponent is not 1, so I'm gonna say whatever is here times whatever is there, right? So I'm gonna say this times that. That would be 3 times 2, then I write my x, and then I'm gonna say the exponent minus 1, so I say 2 minus 1. Okay, then here the exponent is still not 1, so I'm gonna say this times that. Okay, so I'm gonna say negative 5 times 4, and then I write my x, and then I say the exponent minus 1, so I say 4 minus 1. Okay, then here the exponent is 1, isn't it? So the answer is simply gonna be 2 there, right? But you can go the longer method. Remember, you can say 2 times 1 and then say exponent 1 minus 1 there. Then here is just a number. Is there x attached to it? No, right? So it means the derivative of that will just be 0. All right, so now I simplify. 3 times 2 is 6, and then I have x. 2 minus 1 is just 1, right? Negative 5 times 4 is negative 20, and then I have x. 4 minus 1 is what? Is 3. Then I have plus 2 there. Then this is the derivative of f, right? So this one here would be the derivative of f. Pretty nice, isn't it? Let's give you a second example. So we can call that number 1. Number 2, let's just say we have g at x is equal to negative half x to the power of 2, and then plus 6x squared, and then minus pi plus k, right? So how do you get the derivative there, right? Well, it's not difficult, right? It's not difficult. To get the derivative of g, we'll then say, okay, here we see that we have negative half, then we have 2. We're gonna multiply them, right? So we're gonna say negative half times 2, and then I'm gonna say x, right? Then I say the exponent minus 1. What about here? I'm gonna say this times that, right? Meaning I will have 6 multiplied by 2, and then I'm gonna have the exponent minus 1. What about here? Well, here would be our constant, because this is a number. Remember, pi is 3.142 right? So it's actually just a number. What about k? Well, k is not x. We are respecting x here because x is in the brackets here. We are respecting x. So k, we don't respect it. So all of this is just a constant. So the derivative of that will just be 0. For all of it will just be 0. Okay, or you can say 0 plus 0, meaning the derivative of this number here is 0. The derivative of k will just be 0 there. Okay, so the final answer will then be that the derivative is equal to negative half times 2, that is negative 1. So you have negative x, because 2 minus 1 is 1, and then you're gonna have 12, and then x. Okay, then you have x. Then you can actually simplify there, right? What is negative x plus 12? Because these and that are like terms, so you just add the numbers in front. Negative 1 plus 12, that would be 11x. Okay, so this would be your derivative there, right? So I hope that is clear. Now we're gonna look at some notations that I used for this thing, right, to apply our differentiation rules. Okay, so we're gonna use three notations, right? The first notation, f at x, can be represented by saying f at x is equal to 2x squared minus 3x. So the notation is f at x. Let me write in brackets here that it means the notation that we'll be using there, right, is we have f at x, we have g at x, we have p at x, and many more. All right, and then f at x can also be, the equation can also be written like this: y, right, we can write y is equal to 2x squared, yes, 2x squared minus 3x, right? So it means the notation that we are using there is y is equals to something, p is equals to something, any variable is equals to something. So we're gonna say and many more there. Okay, then the third way of representing our equation is that we can say, okay, yeah, that is the two ways that we can represent the equation, right? That is the two ways that we're gonna represent the equation, right? However, the derivative can be expressed in three ways. Okay, the derivative can be expressed as you can say the derivative of f if you have an equation having f at x is equals to something. Okay, f at x equals to something. Then you can also say the derivative of g if your equation is g at x is equals to something. Then you're gonna have dy, that is the first notation there. You can have g at x, p at x, it will just follow the same pattern, right? However, so this is just the first method. However, if your equation is as number 2 there, the derivative can be expressed as dy over dx. Okay, you can say dy over dx, or we can talk about dk over dz, or we can talk about sorry let's write them properly. My goodness, my mind is on the next method of representing a derivative. So it's actually dy over dx, then we can say maybe dk dz. We use a small letter d, or you can say dc over dz. Okay, just depends on the equation, but we're gonna look at them one by one. Okay, then the last method is you can say dx is equals to, this is how you represent your derivative. You can use this method, or you can say dz is equal to, right? It just depends on your what you have there, right? So let's look at them step by step. Okay, step by step. Now the first method, right, if I have number one, if I have, let's say f at x is equal to 2x to the power 4 minus 6, how would I get the derivative? The derivative would be equal to, right, oopsie, I don't know why my mouse does that. So it would be equal to whatever is here times the exponent, because the exponent is not 1, it's 4. So I'm gonna say whatever is here times the exponent. So we have 2 times 4, then we have x, then we're gonna say the exponent minus 1. Okay, then this is just a number. The derivative of a number is what? Is 0. So our derivative there would be 8x cubed. Okay, I know my f at x is now a bit messy, so allow me to cancel it, good people, and just write it quite nicely here. We had 2x to the power 4 minus 6, right? So I'm just gonna maybe erase this mess here, right? Yeah, so that is what we have there, right? So this is what we had for f, right? Then the derivative is this one there. Number 2, what if I had p of x is equal to k plus 3x and then plus maybe 6x cubed? How would I get the derivative there? Remember, x is the variable that we are respecting there. Okay, so I'm gonna say the derivative of p, right, would be I see k. Is kx? No, it means this is a constant, so the derivative of a constant is 0. And then what about here? I see x. What is the exponent? The exponent is 1, so the answer will just be the number in front, so the derivative would be 3. What about this? The exponent is not 1. I see x, so I'm gonna say this times that. Okay, so I'm gonna say 6 times 3, then I write my x, and then I say 3 minus 1. So when I simplify there, I will have 3 plus 18x squared, right, as my derivative for p there. All right, so I hope that you are getting a hang of this thing. All right, what if we have number 3? What if I have k of y as being equal to 2x squared plus 3y cubed, right? And then maybe plus 6 there. How would I solve this? Let me give you some time to solve it, right? Please, you can pause the video and try it out, and then you check the solution. So here we have y. It means the variable that we are respecting, right? The variable that we are respecting is y. So now we're going to differentiate everything in terms of y. So here I see x. I see x. Is it y? No. So it means this is a constant, and the derivative of a constant is 0. I take all of it as if I just have a number there. Then the derivative of a number is 0. Because it's not y that I have there, it's x. What about here? I have y. That is the variable we are respecting. So I'm going to say this times that. Okay? Because the exponent is not 1 there. So I'll have 3 times 3, and then y 3 minus 1. The same way I was doing with x. It's just the same way. What about here? We have a number. The derivative of a number would be what? Would be 0. So it means, oh, oopsie. Remember, you should say derivative. Okay? F prime. K prime. So k prime of y would be equal to 9y squared there. Okay? So that would be the derivative. So what is very, very important to note is, what is the variable you are respecting? Any other variable is taken as a constant, and the derivative of a constant is 0. Okay? That applies to all other methods that we're going to talk about. Okay? So let's just say we have let's say you have y is equal to 8x to the power 4. Now that it's in this form, then they say find dy over dx. What does this mean? Okay, good people, dy over dx tells you two things. This one here tells you that this is your function here. Okay, that is your function there. It tells you that your function is y is equal to something. Then here is the variable that we are respecting. Okay, this one here would be the variable. Alright, so if I have dz over dx, what should you expect? You should expect that the function is z is equal to something, and in that something there, the variable is x. Okay, meaning that if I have z is equal to 2x plus y, it means when I say dz over dx, I'm respecting x, and then any other variable is taken as a constant. And then the z here means my function is z is equal to something, and as you can see, it's z is equal to something. So it means the derivative of this, the exponent is 1, so you just take the coefficient as the derivative. Then this one here, the derivative would be 0, because the variable we are respecting is x. So once we see another variable, it's taken as a constant, and the derivative of a constant is 0. I hope that makes sense. Look at this one there. They say find dy over dx. The dy tells you that my function is y is equal to something, and as you can see, then it says dx, meaning that I have to find I have to respect x. Okay, that is the one that we are respecting. So therefore dy over dx would be 8 times 4, and I'm gonna say this times that. Remember, you are still applying your rules, so you're gonna say 8 times 4, and then you say x 4 minus 1. Okay, so 8 times 4, 8, 16, 24, 32. That would be 32 x to the power 3. Then this would be your dy over dx. Alright, that was example number 1 on this type. Example number 2, let's just say you have p is equals to 2x squared minus 3x plus y there, right? So what would you do? Well, let's say y squared, right? Then they say find dp over dx. What would be the answer there? dp means the equation is p is equals to something, and then dx, x means that here is the variable we're respecting. So here it's x, right? We are respecting x, so you're gonna say this number times that number. Okay, so you're gonna say 2 times 2, then you say x, you say 2 minus 1, the exponent minus 1. Then here then the variable is x, right? We are respecting x, so we just say remember here the exponent is 1, so the derivative will just be the number in front, which is negative 3. What about here? Is the variable x? No, the variable is y. So all of these is taken as a what? As a constant. And what is the derivative of a constant? It's 0. Okay, no matter what the constant looks like, the fact that it's not the letter that it's not the variable we're respecting, the derivative will be 0 for that. So it means dp over dx would be equal to 4x, right, minus 3. Alright, so I hope that this is clear, good people. This is how we use the notations to solve for our derivatives. Okay, so on our next video we're going to look at previous papers regarding this, do a lot of examples on that, and then after that we'll then move to the graphical approach of calculus. So stay tuned.